So let's look at a couple examples of how to graph a quadratic function in standard form. So standard form is y equals ax squared plus bx plus c. And our key steps are going to be this. We're going to find the vertex. Then we're going to find the intercepts. And if we need it, we'll find a value of a couple more points and plug them in and see what we can get. Now, keep in mind, we can always just plug in numbers for x if needed. All right. So you could always just make a table of values. If you're really stuck, you can plug in, 0, 1, 2, 3, and get points. And sometimes it won't be that, too difficult. But the problem is we don't exactly know where to look. And so by finding the vertex and the x and y intercepts, it helps us to focus on the right areas. All right. So we'll come back and maybe look at that table here in a second. So, all right, so let's find our vertex. So first we've got to find the axis of symmetry. And so along with finding the vertex is the axis of symmetry, which our formula is x equals negative b over 2a. So that's the first thing we need to find, x equals negative b over 2a. That tells us right where the center of the graph is. Negative 2 over 2 times 1, which is negative 2 over 2, which is negative 1. So that tells us that the middle of our graph is at negative 1. So it's not a bad idea to kind of identify that. And by the way, let's go ahead and take a moment and label our axes. 1, 2, 3, 4, 5. Okay. So x equals negative 1 is where the vertex is at. Now the vertex lies somewhere on that. And so we've got to plug in negative 1. So we're going to go y equals negative 1 squared plus 2 times negative 1 minus 3. And so that's 1 minus 2 minus 3. And that's going to give us negative 4. 1 minus 5, negative 4. So we'll start to build a little xy table here. So we're finding not random points, we're finding important points. So it's negative 1, negative 4. 1, 2, 3, 4. All right. Now, next we can find the x and the y intercepts. Probably easiest to find the y intercept first, because we're just going to plug in 0. So y equals 0 squared. Remember, we're plugging in 0 for the opposite vertex. So if you're looking for a y-intercept, plug in 0 for the x value. So 0, this is 0, 2 times 0 is 0, minus 3. 0 plus 0 minus 3 is negative 3. So when x is 0, y is negative 3. Now, we know that we're going to get a parabola. We know that it's going to be symmetrical. So there's one point over here. So there's another point right over here on the opposite side. So every point we get on one side of the axis of symmetry gives us another point. All right. Now let's go ahead and find the x-intercept. To find the x-intercept, we're going to set 0 for y. And we're going to get x squared plus 2x minus 3. And we're going to hope this factors, and I think it does. I think this is x plus, let's see, plus 1 and minus 3. Two numbers that add to 2 and multiply to negative 3. I think I got my signs backwards, didn't I? Yep, looks like it. Need to make that a positive 3 because it's got to add to positive 2. There we go. Now we set those equal to 0. X minus 1 equals 0, and x plus 3 equals 0. What makes x minus 1 0? Well, x is 1, and x is negative 3. For our other one, subtract 3 from both sides. So that gives us the point 1, 0, and negative 3, 0. All right, and those points are right here. And those are symmetrical, meaning they're 2 away from the axis of symmetry here and 2 to the left. So I think we got our graph. Here it is. 5 points is plenty. All right, 5 points is good. So we're shooting for 5 points. 3 points is not quite enough usually, but 5 points is good. Now, one little side note too. Notice that the a value is 1. Since the a value is 1, it's going to be the same shape as y equals 1x squared. This is the same shape. All right, and so what does that mean? Well, that means from the vertex, we go right 1, up 1, because 1 squared is 1. That's what the graph of y equals x squared looks like. From the vertex, we go right 2. 2 squared is 4, and there's our next point. Left 1, 1 squared is 1. 2 squared is 4. All right, so really once we find that vertex, everything kind of falls into place. So our vertex, just to kind of finalize this problem, our vertex was at -1, -4. Our axis of symmetry was at x equals -1. All right, let's try another one here. So here we have g of x equals 2x squared minus 8x plus 9. If you want to practice, you can pause and graph this and come on back. And here's what we should get. So first we've got to find the axis of symmetry. The axis of symmetry is x equals -b over 2a. So this is -8 over 2 times 2. That's 8 over 4, which is 2. So now we got our axis of symmetry. X equals 2 is our axis of symmetry. And now our vertex is going to be at g of 2, which is 2 times 2 squared minus 8 times 2 plus 9. So this is 2 times 4, which is 8. 8 times 2, which is 16. And 9. And I think that's going to be 9 and 8 is 17 minus 16, which is 1. So the vertex is at 2, 1. Right? So we found our vertex, we found our axis of symmetry. Let's go ahead and graph those. So our axis of symmetry is at +2. Get our scale here. 1, 2, 3, 4. That's probably good. Okay. So 2, 1 is right there. This is opening up because the a value is positive, so we're expecting it to go up. All right. Now, we got 2 ways to go. We just found 1 point, 2, 1. We can find a couple more. We could find the y-intercept and the x-intercept. Okay. Now, it's going to be the same shape as y equals 2x squared. All right. So, 2 ways to go. One way is to use that shape knowledge there. And since our vertex is right there, we know this. When you plug in 1, you get 1 squared is 1 times 2 is 2. So this is from the vertex. We're going to go right 1 and not up just 1, but we're going to go up twice as far. So we'll see that we're going to end up there. And its symmetrical point is over there. When you plug in 2 to y equals 2x squared, we get 2 squared is 4, doubled is 8. So from the vertex, we're going to go right 2 and up 8. All right, so we'll end up here. So that's using the shape. That gives us our graph, our 5 points. Okay, so that's one method, is just using the shape and using the a value. The other method is to, let's go ahead and find some more points, all right? So we can find the y-intercept, which we need to find sometimes anyways. The y-intercept, we plug in 0 for x. That's g of 0. 2 times 0 squared minus 8 times 0 plus 9. And these things just cancel out, and we're left with 9. So the y-intercept is 9. There it is. Okay, that's our y-intercept of 9 right there. So when x is 0, y is 9. We just found another point. And if we find that point, that's 2 away from the axis of symmetry. So we have a reflection point on the other side, a symmetrical point, because this parabola has to be symmetrical. Now, if we wanted to go look for the x-intercepts, let's see what happens. If we have the x-intercepts, we can plug in 0 for y, or in this case, 0 for g of x. And we're going to need the quadratic formula. Let's see what happens here with the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac. Notice I put that b squared in parentheses, okay, because that negative doesn't really matter. 2 times 2 on the bottom. All right, so we get 8 plus or minus, and we get 64 minus 7. This is 8 times 9, which is 72. And look what's happening there. We get a square root of negative 8, I think it is. Now, we can stop there because this is imaginary. It is not a real number. And since it's not, why is it not a real number? Because of that negative under the square root. So we got imaginary. So that means that there's no x-intercepts. And we kind of know that, hopefully, because it has an a value of positive 2. That means it opens up. And our vertex is above the x-axis. So it can't find that. It can't hit the x-axis. So there's no x-intercepts here. All right. If you were graphing this and you forgot the whole shape thing and all you had was these points right there, okay, probably what you would do is go find another point, just plug it in. All right, plug in x equals 1. And when you plug in x equals 1, you're going to find out that g of 1 is 2 times 1 squared minus 8 times 1 plus 9. And that's 2 minus 8 plus 9. And that is going to be 3, which is where we had it, and its reflection point. Once you get 1 point on one side, you can just reflect it to the other side. And there's the graph. All right. So there's some techniques, all right? Several ways to go. Find one that works good for you and go with it, okay? Now, one last little situation, one example would be an application problem here. So let's see what happens here. We got the height of a certain ball that's thrown off of a 20-foot building can be calculated with this function right here. For the height h of t and feet time in seconds. All right, so h is the height, t is the time. And we want to find the maximum height of the ball, then find the time the ball will hit the ground. Okay, so this, now notice this equation. It's quadratic. Now, it's written a little reversed, so really the h value is, or the a value I should say, is negative 16. If we rearrange this, we can see better that the a value is negative 16. So what's going on here? Well, what's going on is we have a parabola that looks something like this. And it will have a highest point at the vertex, and it will have a lowest point here where it hits the ground. All right, so this is something 0, and this is the vertex. So we want to find the highest point, we'll find the vertex, okay? So we need to find the vertex, and then we're going to need to find the x-intercept, okay? So that's really all we're looking for, okay? So let's find the vertex. In order to find the vertex, we need the axis symmetry first, and that's going to be x equals negative b over 2a, which is negative 10 over 2 times negative 16, which is, what is that? It's 10. The negatives cancel, and so we got 10 over 32, and that's 5 over, divide both of them by 2, 5 over 16. Okay? And so our vertex, then, we need to plug that in. We need to find h of 5/16. And we'll use our calculator for this. All right, but we got negative 16. It's easiest to probably leave it as a fraction here like this for the moment. And then there's an application problem, so we can let our calculator do some work for us here. So we've typed that into our calculator, and we've got about 21.5625. Actually, that's an exact value there. All right. So that's our maximum height. So our max height is at 21.56 feet. And this is at the time. Our time was 5/16 at 5/16 seconds. Okay, so our vertex gives us two things there. It gives us the time, that's the x value, and it gives us the height. Now, we could also go like this. Let's go to our calculator here, and if we enter the equation there, y equals negative 16x squared plus 10x plus 20. And if we go tap on it, we get the highest point. There it is. And that's at 21.53. You can see that 0.313, that is 5/16 as a decimal. Okay? All right. Now we need to find out algebraically here where the x-intercepts are. That means we want to set it equal to 0. So we're going to have 0 equals negative 16t squared plus 10t plus 20. Now we could plug all these numbers into the quadratic formula right now, but here's a little suggestion just to make things a little easier. Notice all of these are divisible by 2. If you can divide all these by the same number to knock them down a little bit, you can make your life a little bit easier. So this would be negative 8t squared, divide them all, plus 5t plus 20. Nope, 10. And notice we did 0 divided by 2. We did divide that side, it just doesn't change. Okay, now we can go to our quadratic formula. And that'll give us t, in this case, instead of x, equals negative b plus or minus the square root. B squared minus 4a. Watch out for your negative signs. That changes everything. All over 2a. All right, that gives us negative 5 plus or minus the square root of 25. And that'll be 32, positive 32, because the negatives times 10 is 320. And we're going to go to our calculators in just a second. Negative 5 plus or minus 345. So I find that I make mistakes in the calculator more if I'm typing all these things in the calculator. The fewer keystrokes, the better. And so if it's easy enough and safe enough to do the arithmetic by hand, then work it out. There. So, okay, let's see. This was a little off there. So we have negative 5. Let's go there, plus, and 345. All right. Okay, so we type one answer in and we get a negative number. Well, that's not what we want. This is time. We're looking for time in the future. Okay, what we just found is this right there. We just found that point, that intercept. We don't want that x-intercept. We want this one, and that's at 1.473, and that is this other x-intercept over on the right. So that is about 1.473 seconds. All right, and that is when it will hit the ground. Okay, so we know that we have a max height at 5/16 seconds of 21.56 feet, and it hits the ground at 1.473 seconds. All right, So the key there is to translate it into terms of intercepts and vertices. The vertex is where the maximum is, and the x-intercept is where it hits the ground, where the y value or the height is 0. All right, so keep practicing, and it'll start to all come together. Thanks a lot.